Alright guys, welcome to our integral concept and applications college board practice work here. So let's go ahead and begin here with this one. If b is somewhere between 0 and 2, for what value of b would this function be at a minimum? Okay, and so that's the question. They want to find a minimum, and as you guys know, when you want to find a minimum, then we're going to be doing the candidates test. So we have this function, I'll call it y of b. I'll just create a new variable, I'll call it y. But y of b, where when you plug this b into this function here, it's going to give you different outcomes, right? And our goal here is to figure out what value of b will result in having a minimum. Now, as you guys know, to do the candidates test, your input variable always goes here, and the thing you're trying to find the minimum of, in other words, this function up here, we'll call it y of b, goes here. And when you do the candidates test, you always put your starting point and your ending point, so 0 and 2, but you also need to find your critical values. So we need to find out what y prime of b is. Now, if I want to take the derivative of an integral function, we have the second fundamental theorem of calculus to help us out. The second fundamental theorem of calculus tells me that I can drop that integral and then put the b in the place of the x and get the integral, the derivative of that. There you go. Now, critical values are where the derivative is equal to 0. So I'm looking for wherever cosine of e to the b equals 0. Now on the unit circle, cosine equals 0 at two different places. One of the places where cosine is equal to 0 is at pi over 2. The other place is at 3 pi over 2. Now those aren't the answers because that's what would have to go in here to make cosine equal 0. So that means that e to the b would have to equal pi over 2, or e to the b would have to equal 3 pi over 2. And the way that we're going to solve this is by taking ln on both sides, because when you take ln, it cancels out the e. So if I ln the left side, I'm left with b, and then if we ln the right side, I get this. Same thing on the other one. We have ln of e leaves me with b, and then we have ln of 3 pi over 2. Now notice this is a calculator problem, so let's go ahead and take a look at our calculator really quick. Need to figure out what ln of b and ln of 3 pi over 2 is real quick, so let's do that. Ln of pi over 2 is 0.451, or 0.452 actually, and ln of 3 pi over 2 is 1.550. So those are going to be my two critical values. So I'm going to come back to this now. And as you can see, ln of pi over 2 is this one, and ln of 3 pi over 2 is this one. So they've got both critical values there. So I'm going to put them both in my table. All right. Now, from here on out, we're going to let our calculator tell us which one of these will give us a minimum value, because that's what we're looking for. So I need to figure out what y of b is. Y of 0. I need to figure out what y of 0.452 is. I need to figure out what y of 1.550 is, and also what y of 2 is. Okay. Now y of 0 is easy. That's just going to be 0 because you guys can tell up here if you plug 0 in, since the top and the bottom are the same, that's just going to be 0. That's one of our integral properties. These other ones, though, we're going to go ahead and use our calculator to help us out in getting those. Okay, so let me go ahead and clear this out real quick, and we'll go back to our calculator. Now, we're going to push y equals, and I'm going to put the function in there. Now, this is an integral function, so we're going to need to put an integral in there, and we're going from 0 to b, but we can't put b in our calculator, so we need to put x. And we're doing cosine of e to the x power, right? X here. Let's Get out of there now, go back to the home screen. So we need to figure out what y of all these values are. So let me bring them back real quick. We want to figure out what's y of 0.452. Enter. So there's that one. We also need to figure out what is y of 1.550. Second. Enter will bring back the same thing. Just go back and replace it with what I want. And then finally we need to figure out what is y of 2, the last one. We get that. All right, so on our chart then we can go back to our screen, and I'll put these numbers in here now, and we can see which one is the minimum. For 0.452 I get 0.135, and for 1.550 I get negative 0.536, and then for y of 2 I get negative 0.228. And as you guys can see, this one is the minimum. The question wants to know what value of b will give us that, and the answer is 1.550. So on this one the answer is D. So a lot of concepts in here. The ones that I think are most important is of course recognizing that this is a candidates test question. Another thing that was important about this problem is recognizing that to find the candidates you had to take the derivative of this and set it equal to 0. Now after that you end up in kind of a trigonometry world, which is a little sad because you have to remember how to solve your trig functions. But there you have it. So that's number 1. Let's go ahead and move on to number 2. The rate at which motor oil is leaking, let me change my window here, it's not showing quite right, just a moment. All right, there we go, that's a little bit better. The rate at which motor oil is leaking from an automobile is modeled by this function L here. So this tells you how quickly oil is leaking from the automobile. It's measured in liters per hour. Time is obviously therefore measured in hours. The question is how much oil? Well, how do you turn a rate into an amount? Hopefully you guys know that would be integrating the rate. Now it says during the first half hour. So we're starting at time 0 and we're going up to a half hour, which would be 0.5. Okay, but from there I think I'm going to let you guys go ahead and figure the answer out from there. But you would just do it on your calculator, of course. Let's go ahead and move on to our next question. So the graph of y equals f of x is shown above. A1 represents this area and A2 represents this area. And when they say these A1 and A2 are the areas, they're talking about the positive values. And the reason they say that is because this piece down here is, we know that this is a negative value for an integral, but they're just giving us the positive value of that area. So in other words, like let's say that A2 equals 10. Well, that means on the graph up here, this integral would actually be negative 10 because it's below the x-axis. So A1 and A2 are just the positive representations of those areas that represent the areas of the shaded regions. And then what they want us to do is find out what does this integral expression equal using the values A1 and A2. Well, let's go ahead and start here. Negative 4 to 4. That means I'm going from here all the way up to 4. So in other words, that's both of those pieces put together. Okay? So that first piece right there, that piece is equal to A1 combined with A2. Now, we know that it's supposed to be a negative value because it's below the x-axis, so I'm going to put minus A2. Okay? Now as for the next one here, so I'm going to put that in parentheses. Now we have minus 2, and then we have this one. So that's from negative 4 to negative 1, right? No, I'm sorry. I take that back. It says from negative 1 to 4. That's this one. And once again, that's the A2 value, right? But it's negative. All right, so let's go ahead and simplify this expression a little bit. We have A1 minus A2. And then simplifying that, you get plus 2a2. And then you can combine these two terms together. Oops. Negative a2 plus 2a2 is positive a2. And there's our answer there. So I would argue that our answer is option D there. All right, now suppose that k is some number between 0 and pi over 2. And the area under the curve of cosine from this k value to pi over 2 is 0.1. Now, when I see that phrase, area under the curve, I'm thinking integrals, right? And so the area under this curve, so the integral of cosine x from k to pi over 2 is 0.1. So how are we going to solve this? Well, how about we actually integrate this and do the fundamental theorem of calculus? Because I need to get rid of that integral somehow. Okay, so I'm going to go ahead and integrate this. So I'm going to integrate that. If you integrate cosine, you end up with sine. And then using the fundamental theorem of calculus, then we can just plug in the pi over 2 and the k. Now this equals 1. Now I'm going to subtract 1 from both sides. Let's see. I believe that would be negative 0.9. And then I'm going to divide both sides by a negative. And now I need to find out what sine of what equals 0.9. Now that's not a unit circle question. That's a it's going to have to be an arc trig function. So how do you get rid of the sine? What you do is you arc sine both sides to get rid of the sine. If you arc sine the left side, the sine goes away and just leaves you with k. Arc sine the other side, you get that. And so from there, you're going to punch that into your calculator. Show you guys how to do that real quick if you're not used to doing that. Let's take a look. All right, so we're going to do second, and then you push sine, and that brings up arc sine. So we have 0.9, enter, and I'm getting 1.120. And so I would argue the answer is D. All right, question 5. What is the area of the region in the first quadrant bounded by the graph of this and this? I want you guys to notice that this is a non-calculator question, and I understand that since this is homework, you guys might be tempted to go ahead and just work it out with a calculator anyway. I would encourage you not to, because when you guys take your AP exam, you're not going to be allowed to use your calculator sometimes. So you do want to know how to do this stuff without the use of a calculator. All right, so we don't really know what e to the x over 2 necessarily looks like. You might, if you remember your pre-calculus pretty good, you might know it looks something like that. It would be helpful if you knew that. But it's not necessarily needed. You can still kind of get it without knowing what the graph looks like. This one here is a vertical line. Now that is important for you guys to know. That's a vertical line and not a horizontal line, because that tells you where you're going to stop. Now they're telling you that you're only in the first quadrant. So that would mean we're only in this area. Okay, but like I said, you guys may not really even need to know what this graph looks like, because the point is that even if you drew the graph a little differently, like let's say you did this, it doesn't really matter. We're still going from 0 to 2, and we want to find the area under the curve, and that picture is just a representation of what we want, right? So how do you find the area under a curve? Well, you integrate from your starting point to your ending point, like so. At that point, you're going to go ahead and do some u substitution. So with exponential functions, a lot of times your u is just going to be the exponent. And I want you guys to understand that's the same thing as 1/2 times x. So then when I tell you that the derivative of u with respect to x is 1/2, That'll make more sense. And we want to get dx by itself. And if you multiply both sides by dx and then by 2, you're going to end up with 2 du equals dx, which means that we can transform this entire expression here into be e to the u times 2 du. But as you know, I'm going to take that 2 out and put it to the front. And anytime you do u substitution with a definite integral, you also need to change the limits. Okay? And how do you do that? You plug those numbers in to your equation for u. So u equals x over 2, and I'm going to plug 2 in. 2 over 2 is 1. And if you plug 0 in, 0 over 2 is 0. So my limits have changed. Now the integral of e to the u is, of course, e to the u. And then we're ready to go ahead and apply the fundamental theorem of calculus to this. So we have 2 brackets e to the u minus e to the 0. All right, and so right now we have 2 e minus 1. E to the 1 is e, and e to the 0 is 1. So we have that, and if you just distribute, you've got your answer there, which would be option A. All right, moving on to number 6. Notice that we do get to use a calculator on this one. That's nice. Pay attention to those little details. All right, so if f of x is equal to this function here, what is the average value on the closed interval? I know you guys know how to do that one. Got to know how to do that one. Average value is 1 over b minus a, integral from 0 to 6 of your function. And I think I'm going to let you guys go ahead and handle it from there on your calculator. All right, let's go ahead and move on to number 7 here. Oh, another average value question. So I'll direct you to go back to question 6 if you haven't seen that one yet, and see how I set that up, because that's how you'll handle this one as well. Let's move on to question 8, and once again we have another calculator question. Awesome. So they give us the graph of a function f up here, and then they define h as this function here. They want to know if we were to put these in order, which one is greatest, which one's least, and so on. Okay, well let's go ahead and do that. So first of all, what's h of 2? Okay, well, according to our graph, that would be the area under this curve here. And that's a positive area. Now, a lot of times with these types of questions, you guys, so as not to be ambiguous, you're not going to be able to know the numbers necessarily, but how these are usually set up, because I've seen these types of questions many times, is one of them is going to be positive, one's going to be negative, one's going to be 0. And you know that based on this integral here, the fact that that area is above the curve, that's a positive value. So I'm going to put a positive here next to my h, just so I remember that's the positive, which to me kind of indicates, I could be wrong, but that might indicate to me that we're probably looking at the greatest value. So h of 2 is probably the biggest one. Let's go ahead and take a look at h prime of 2. Well, now that's a little bit different. So here I'm going to start out by saying h prime of x. So let's find h prime of x first. So if you want to take the derivative of h here, that's going to cancel the integral out and just leave you with f. And therefore, h prime of 2 is f of 2. And f of 2 is going to be the y value of this graph that we're looking at, which is right here, and sure enough, that's 0. So now I've got my h of 2 as my positive value, h prime of 2 is my 0, and if you were really in a rush, you could probably just assume that the answer is probably going to come out to be this one here at the bottom, because that gives this one as the greatest, this is the 0, so this one will probably come out negative. But let's go ahead and do it anyway. It's not that hard, so we'll go ahead and go one more step here. So if h prime of x is f of x, then h double prime of x is f prime of x. And so h double prime of 2 is f prime of 2, and what that would mean is the slope of my graph at 2. And if you guys look at this point here, the slope is pointing in a downward direction, so sure enough, there's your negative value. And so our guess was right. You have that. So a lot of times when you guys have these questions where they ask you to compare 3 quantities, they come up every once in a while. I know I've given you guys these questions a couple times this year. Usually it works out where one's positive, one's negative, and one's 0. You're not expected to get actual number values all the time. Let's go ahead and move on to the next one. Okay, so the figure above shows the graph of the function f. And they're giving us this other function here, which is the integral of f, in other words, the area, right? And they're telling us that this shaded area has an area of 2, but you got to understand, since that's under the x-axis, it's actually negative 2, right? So now, this question kind of struck me as funny. They want to know what's the value of g of 2. And hopefully you guys understand that means you just plug 2 in here. And this just represents the area. This just represents the area under the curve from 1 to 2, which is the exact area that they already gave us the answer for. So it was just kind of a weird question to me, because kind of like, but I guess the purpose is they want to know that you do know that that represents the area under the curve. So they basically told us the answer. It's negative 2. Let's go ahead and take a look at another one. So for x greater than 0, they want to know that what the derivative of this expression here equals. Now, when you see when you're taking a derivative of an integral function, you guys should be thinking second fundamental theorem of calculus. Okay. Now, if it was the simple one where you just have a number down here, which we do, and just an x up here, then it would be simple. You would just cross off the integral and drop the x in. However, we're not quite so fortunate as to have that simple situation, because even though we do have just a number down here, this is not just an x. That's a square root of x. So now we've got a function there. And so there's the simple second fundamental theorem of calculus, but then there's the one that's a little bit more complicated that I shared with you guys a little while back. It looks like this. So let me remind you of how it works before we begin. When you take the derivative of an integral function where the limits are different than the standard simple one, basically how it's going to work out is you're going to drop the integral and you're going to plug in the top one and the bottom one, and they're going to be subtracted. And that's just because that's the way the fundamental theorem of calculus works. But remember, we're taking the derivative of this. So when you do that, you would have to take the derivative of the inside also. So it's going to be h prime of x and g prime of x. So that's that little formula for the more complicated version of the second fundamental theorem of calculus that we talked about. Okay, and we're going to be doing that here on this problem. So let's begin. So first of all, we're going to drop the square root in there. So that's going to be 1 over 1 plus the square root of x squared times, and then we're going to multiply that by the derivative of the inside. The derivative of the square root of x is 1 over 2 the square root of x. Okay, now I just memorized that, but you guys can figure it out in the long way by changing that square root to a half power and just doing the power rule. But that's the derivative of a square root. Then we do minus, and we plug in the 1. And we multiply it by derivative of 1. Now, since that's just a constant, the derivative of 1 is 0, and when that happens, that whole piece just goes away. Okay? And so we have this. Now, we might be able to clean this up a little bit, but I don't know how necessary it is. They might write their answer a little bit differently, so we have to kind of be prepared to see different things. But this can be simplified to just be x. So let's go ahead and see if that answer's in there anywhere. I see it. Looks like option A to me. All right, so question 11. It says you can use a calculator, but it's kind of I don't see how you would use a calculator on this question, honestly. So let's go ahead and see what we can figure out here. So they're telling me that f is continuous, it's positive, and decreasing. Now remember, positive means above the x-axis, right? So we have this function f that is positive and decreasing. So maybe something like that. Now, g is this function, which is the integral of that from x equals 2, so we'll start here, up to any value x. Okay. Now, f has to stay above the x-axis the whole time, so it can't be a straight function because eventually then it would cross the x-axis, right? So we know it's got to probably be plateauing at some point like that. Now, the area under the curve is what we're looking for. Now, they want to know which one of these tables could be a table that represents G. Well, let's go ahead and try. So let's start by plugging in 1. So if I plug in 1, well, notice that my limits are backwards. And you guys know that when your limits are backwards, you have to change the sign, right? So now typically, if I was to start back here, yes, the area from here to here would be positive. But since my limits are backwards, that's going to actually change it to be negative. And therefore, when x equals 1, I know that I have to have a negative outcome for g, which means that this is a possibility because my g is negative, and this is a possibility because my g is negative. Neither one of these down here that are going to work. So that's nice. We've ruled it down to a 50-50 chance here, right? Now let's go ahead and plug in 2. Now that's not going to help us too much. You'll see why in a second. But if we plug in 2, you guys might remember from your integral properties that anytime these match, the answer is 0. And the reason that's not helpful is because both of my options here both have that. So now we're down to this other option here, and I myself was staring at this for quite some time. I couldn't get the answer, and then I asked my student teacher here for help, and she helped me out. So let's see why one of these will work and the other one won't. All right, so what we want to pay attention to is a very subtle detail. As I go from x equals 1 to 2, the area increases by 2. And then as I go from 2 to 3, here the area is increasing by 1. So let's look at this. On this table, the area is increasing by 2 for the first two, but for the next one, it's increasing by 3. And here's where the subtle difference lies. Now I know that this area is negative, but ignore the sign right now. Compare this area with this area. Which one would have a greater area ignoring the signs? Well, this one would because it's taller, right? They have the same base, but the one to the left is taller. And therefore, this area from x equals 1 to 2 should be more than this area from 2 to 3. So as I go from 1 to 2, the area should increase more than it does from 2 to 3, and that would give me option A. And honestly, I could not figure that one out. Sorry that they're like that on these questions sometimes. But hey, the good news is we could easily boil it down to 2 options. From there, may the force be with you. All right, let's go ahead and take a look at number 12 here. Hey, it's another second fundamental theorem of calculus question. Only it's not a simple one, right? It's not the one with just an x at the top and a number at the bottom. On this one, we have an x cubed. And so when we do that, we have to follow through with our little process here. So if you didn't watch the previous questions, I think it was, let me figure out which one it was. I would encourage you to rewind to question 10 because it's the same strategy. And I think I'm actually going to let you guys go ahead and see if you guys can figure this one out based on what I showed you in 10 already. So, and there's another one. Now this one's even easier. Well, actually, let me see. Yeah, it's a little bit easier. I'll go ahead and work this one out. It's slightly different, but here we go. So they give us an integral function, and they want to find the derivative at x equals 2. So the first thing we want to do is find the derivative. Now, when you take the derivative of an integral function, you could do the second fundamental theorem of calculus. Now, This one is the simple one. It's the one where you have just a number down here and just an x up here. When that happens, you just drop the integral and put the x inside, and voila, you have your derivative. So we're going to go with that. And then from there, if I want to find f prime of 2, all you got to do is plug it in. And 2 to the third is 8. 8 plus 1 is 9. The square root of 9 is 3. So let's go ahead and move on to number 14. So the figure above shows the graph of f, which is this. A lot of times when we look at questions like this, the graph that they give you is this function, but that's not the case on this problem. On this problem, the graph of f is this whole thing. So that's the graph of the integral function. They want to know, what could the graph of g of x be? Well, g of x, as you may notice, is the integrand here. And we just need to get rid of that integral. How would we do that? Well, we would take the derivative. Because when you take the derivative, according to the second fundamental theorem of calculus, this is just going to become g of x. So g of x is the derivative of f. In other words, g is the slope of f. Now take a look at f. What do we know about the slope of f? Well, first of all, we know it's positive because it's going in an upward direction. So we know that g of x would have to be positive, in other words, above the x-axis. We also see that f has a constant slope, a non-changing slope. So we would know that g would have to be constant. Now on a graph, that means like a straight line. So I'm looking for a line that is straight and above the x-axis, and that would be option A. All right, so for number 15, we have a graph of a piecewise linear function here. They're asking us for the value of the integral from -1 to 4. And so basically we need to find the area of this trapezoid and the area of this trapezoid, because we're going all the way from here to here, so they want both shapes. The area of a trapezoid is height. So in this case, the height of that trapezoid is 2. Height cut in half, multiplied by the sum of the bases. So the top base is 1, the bottom base is 3. Okay, and so that trapezoid comes out to have an area of 4. The bottom trapezoid has a height of 1. So the height is 1, and we're cutting that in half, and the bases, this base is 2, and the bottom base is 1. And that's going to give me a total of 3 cut in half, which is 1.5. But we got to keep in mind that's below the x-axis, so that's actually going to be a negative area. And so when we put these two things together, what we're going to end up with is 2.5. All right, let's move it along. All right, so for question 16, it's written up as a calculator question, but just so you guys know, a lot of times calculator questions don't require calculator. It just means you can. They put the questions in a set, and so some of the questions in a set would require a calculator, but not all of them. And this is an example of one where you really don't need a calculator at all. It's not a calculator type of question. So what they're telling us here is that big F prime is equal to little f. So if big F prime is equal to little f, then that also happens to mean that big F is equal to the integral of little f. These two statements are pretty much equivalent ways of saying the same thing. Okay. So they want us to evaluate this expression here. And what catches my eye right away is they've got a little something sitting there in parentheses. And we don't want a little something there other than just x. We don't want the 2x in there, we just want x. So how do we deal with that? Well, we're going to do u substitution. I'm going to let u equal 2x. I'm going to find the derivative. I'm going to get dx by itself. I'm going to rewrite my integral as f of u and then du over 2. But I'm going to go ahead and put that 1/2 in the front now instead of putting it over 2 on the side of the integral. We also need to change these values By plugging in 3, I get 6, and by plugging in 1, I get 2. And so now if I were to integrate this, the integral of little f is big F, right? So the integral of f of u is big F of u. And then we're going to go ahead and just plug in what we have using the fundamental theorem of calculus. So it's going to be 1/2 brackets big F of 6 minus big F of 2. And then if we go ahead and distribute the half, we'll have our final answer there of E. All right, so for question 17, a city is located beside a river and it has a rectangular boundary to it. The population density of the city at any point along a strip X miles away from the river's edge. So any distance away from the river, I guess, would be like this, right? So we'll call that length there X. The population density of the city at any point along a strip X miles from the river's edge is F of X persons per square mile. Which one of the expressions above would give us the population of the city? This is a pretty weird question, but let me explain it a little bit and we'll see if we can help it make sense. So, and this is kind of true in general. If you guys have ever been to like a city where there's, like for instance, next to an ocean or something, well, that's a really attractive place to live. And so there's going to be a lot more people close to the ocean, or in this case, a river, than there are people away from it, because everybody wants to live here, right? And so basically what they're saying is that the closer you are to that river, the more dense the population is. In other words, there's more people. So what we have here is we have X is going to go down here, but I don't want you guys to think X means this length. It doesn't. X is a changing value, which means that here X equals something, and there the population is pretty dense. Here X is another value. That's X miles away from the river, and there the population is even less dense. So actually, along this vertical line here, we have a certain population density, and along this line here, we have a certain population density, and so on. As we get farther away, the density of the population is less. Okay, so now let's go ahead and we'll label these a little bit, actually. So I'll call this X1, X2, and X3, and each one of those represent a distance away from the river, and then there's a certain density. So like right here at this point, let's just say there's like maybe 100 people per block or something. That's probably too few, but we'll just say that. But notice that this is 7 miles high, so that means that every block along this strip is going to have that density of about 100. And so the density along that one strip is going to be 7 multiplied by the density at that particular value of X. So whatever the density is at that value of X, multiply that by 7, and that's going to tell you basically the number of people that live on that strip. Okay? And then you're going to do it again for the next one. You're going to have 7 multiplied by the density at X2. And so on. You're going to keep doing that for X3, X4. Now technically there's an infinite number of X's. So how do we add together an infinite number of things? Well, we do an integral. Right? We're going to do an integral. Now, f of x represents the population's density. So instead of just putting density of x, I'm going to rewrite this now as 7 times f of x. Okay? And we're starting here when the distance is 0, and we're going to go out till we get here, and that's a total distance of 4. And so this little formula here is the one that could tell you the density of the population. or the total number of people that exist in that particular city. And so our option there would be B. Since 7 is a constant, you can go ahead and move it out to the front, which is what they chose to do there. All right, for time t greater than 0, the position of a particle traveling along a line is given by a differentiable function s. So this is the position function. Now, if that's the position function, hopefully you guys know that s prime is the derivative. S prime represents the velocity. So that's something that we need to know to do this problem. So we have a position function given by s, and therefore s prime represents the velocity. Now, they tell us here some information that's actually not horribly necessary, but to me it's just kind of distracting, honestly, this entire sentence here. We don't really even need it, but we'll read it anyway. They say that from 0 to 2, the position is increasing. Okay, so imagine this particle moving. Well, on the time interval from 0 to 2, it's increasing its distance, and it's increasing meaning that it's moving to the right. And then on the interval for anything greater than 2, for all time values past 2, the particle's distance or the position starts to decrease, so the particle actually starts going backwards. Now, that could matter depending on the way they decide to set this question up, but for this one, it actually doesn't matter. Let's read on and see what else we can find. Which of the following is the total distance the particle travels on the interval from 0 to 5? Well, this whole piece here just becomes kind of irrelevant because we learned in our class that the way that you find distance, I'll put dist just so we don't get it mixed up with displacement, distance is the integral of the absolute value of velocity. And we're going from 0 to 5. Voila, pretty straightforward. This wasn't necessary at all, but it could have been relevant because they could have actually written the question in a slightly different way. But this way is fine. Okay, number 19. We're getting there, almost there. Which of the following is equal to this integral? So which of the following is equal to this? Well, I'm not sure if there's a more awesome and fast way to do this, but the only way I can think of doing is actually just to find the answer and then see which one of these have the same answer. So the integral of sine is negative cosine. And then we just go ahead and plug the stuff in, right? And once again, you do need to know your trig values to answer this question. For those of you guys that have just been looking on a calculator or a worksheet this whole time to get your trig values, that's not going to help you on the day of your AP exam. You're going to need to know those trig values. So maybe we'll make some time to play around with our unit circle a little bit and get that memorized. Anyway, cosine of pi is -1, and since there's a negative in front, that's going to be a positive 1. Cosine of 0 is positive 1, and since there's a negative in front, that's going to be now a -1. And then double negatives makes a positive. So that one comes out to be 2. All right, so basically what you're going to do is you're just going to go through all of these, and you're going to find which one of these also equals 2. All right, let's do the first one. Maybe we'll get lucky. The integral of cosine is sine. Oops. And then we're going to go ahead and apply the fundamental theorem of calculus. All right, so this is 1 minus this one is -1, and we got lucky. I'm going to guess that that's the answer. So at that point, if I was taking the AP test, I would just stop there and say, I'm going to try my luck and say that's the answer because they already match. It's possible that I did something wrong somewhere and they just matched by chance, but not likely. And that's going to save me some time rather than have to go through all of these. And I just want to double check, but yep, sure enough, that is the answer there. So let's go ahead and move on to number 20. Last question. Let f be a differentiable function such that we have this initial condition. The slope is less than or equal to 3 for all x. So the slope is never greater than 3. of the following which is not a possible value for f of 2. All right, so let's go ahead and graph this a little bit. I've got a point here, 0, -5. That's right here. And here we've got f of 2, so that's going to be at 2. Now, let's try -10. Can f of 2 equal -10? Well, let's do that. If f of 2 equals -10, then we have this point here at 2, -10. Now, the slope has to be less than or equal to 3. Is this slope less than or equal to 3? Yeah. So far, that one checks out. So we're good on that one. We're looking for the one that won't work. So let's go ahead and keep looking. Let's keep up the search. Sorry. All right, there we go. Let's try -5. So at 2, if I put -5, that's a slope of 0. Is that less than or equal to 3? Yep, we're good. All right, let's try another one. How about 0? If I do 0, f of 2 equals 0, then I would put a dot right about here. All right, now that one might be greater than 3. Let's see. I'm going over 2 and up 5. So that's 5 over 2, which as a decimal is 2.5. That's still less than 3, so that's still okay. Let's keep looking. Trying to get rid of all this stuff. Sorry. All right. Too far. Oh, well, I'll just redraw it. All right, now we got to do the next one. 1. So, can f of 2 be equal to 1? Well, if that's the case, then I would have a dot right about here. That's over 2 up 6. That's 6 over 2, which equals 3. We're still safe because you can equal 3. So that was good. So that means we've already proven all the other ones work. So that one, the last one is going to be the one that doesn't work. We can still test it just to be sure, but it's already going to fail. I know it. And so, can f of 2 equal 2? Well, if I did that, then it's going to be up here. Now this line has a slope. This line has a slope of over 2 up 7, and 7 over 2 is 3.5, and that slope is not less than or equal to 3. Okay. So, there you guys have it. And that'll close us out for the day. That's one way to do the problem. I think there might be another way to do this problem too, by the way. We know that the slope has to be less than or equal to 3. So mx plus b equals y. Right? So if you plug in 2 for x, you're going to have 2m minus 5. And then you could just try plugging in these numbers and see which one of these numbers will give you a slope that is not less than 3. And you'll have your final answer. But anyway, a few different ways to handle it. We'll see you guys in class. Bye-bye.